Hello, and welcome to Factoring Polynomials. Now, in general, I like to keep these videos 15-20 minutes at most. I actually prefer 10 to 15, but this is factoring, and I want to keep it all together in one video. So, here we go. Hold on. But I'm not going to go fast. We're going to be complete. If it takes 30 minutes, it takes 30 minutes. Let's talk about factoring. So, first of all, if a polynomial cannot be factored, it's said to be prime. And we just need to keep that in mind. I want to throw that out there. Not every polynomial can be factored. These terms or these skills I'm about to show you. And if it cannot be factored, it's prime. But here we go. So we have 4 different ways we're going to look at factoring. And really, 3 of them hinge on this idea of the greatest common factor. Now, the greatest common factor, which will be abbreviated GCF because I'm not writing that out so many times, it's the largest common factor shared in common with all the terms of the polynomial. Largest common factor. So let's take a look at, say, let's look at 6a squared and 10a. Why not just start with number 1? 6a squared. If I were to break this down, I could write 6 as 2 times 3, and I could write a squared as a times a. 10a can be written as 2 times 5 times a. Now, the largest in common that's a factor. So, they both have a 2. They both have an a. This tells me that my GCF will be 2a. Now, what happens if I take out the 2 and the a? I'm left with a 3a. What happens when I take out the 2 and the a from the 10a? I'm left with a 5. Okay, so we would say 6a squared plus 10a is equal to 2a times 3a plus 5. That's it, right? To factor out the greatest common factor, we list all the factors of the first term, the coefficient of the first term, and then write out the variables if you feel like it. I'm going to show you other ways because I didn't necessarily write out all the factors of 6 and 10 here. I listed the proper factors because I knew 6 didn't go into 10. But let's try this again. All right, trying this again, what do we have? We look at what they have in common. So I'm going to use red for in common. So my GCF. 8 and 7 have nothing in common. They both have x's, x to the third and x squared, the largest in common. So they both have an x, but at most, the largest, they both have x squared. Looking at the y values, the first one has a y squared, the second term has a y, so in common is just the y. So if I wanted to factor 8x to the third y squared minus 7x squared y, this would equal xy multiplied by, let me see, if I took out an x and took out a y, I'll still have the 8. I'll have x squared. Oh, what? I even said it out loud, and I didn't write it down. There are 2 x's in common, right? They both have an x squared. The other one has an x cubed, so it has more. Don't let me get away with that. Hopefully, if this would have been in class, somebody would have shouted it out. Hopefully, you were just like, wait, and then you went through with the recording until I found it. Mess myself up here. Here we go. All right, so 8x cubed y squared. I take out the x squared and I take out a y. So I have 1 x remaining, I have 1 y remaining, and I have the 8. I have the minus sign. I have the 7. I took out an x squared, I took out a y. All right. I'm going to bring these all together. I'm going to do a little summary on these 4 problems, but let's do them all worked out first. I look at 10m squared, 4m, and 2, and I see that they all consist of even numbers. So I know 2 will go into all 3 of those terms. Now I look at the variables. M squared, M, no variable. They do not have something in common with all 3 of them, so it's not in the greatest common factor. This tells me that 10m squared plus 4m minus 2 will be equal to 2 multiplied by 5m squared plus 2m minus 1. It's really just a factoring out, so I'm dividing by this greatest common factor each time. What is left? Well, 2 is 2 times 1. So if I take out the 2, I'm still left with the 1. Right? We always have that 1 placeholder. All right, now, very important. Terms are only separated by addition, subtraction, and when we get into equations, equal signs. So this 3y times y plus 4 is one single term. Negative 5 times y plus 4 is one single term. So what do these two things that are underlined have in common? It looks like the factor, right, because they're factored. The greatest common factor is y plus 4. Huh. Well, what does that look like? Well, 3y times y plus 4 minus 5 times y plus 4 is... Now, the y plus 4 is already in parentheses, so let's just let it keep those. Maybe it feels more comfortable, a little security blanket. What's left? Well, in this first term, if I take out the y plus 4, all I'm left with is 3y. In this second term, if I take out the y plus 4, I don't want to cross over those, I am left with a minus 5. So each time, notice, in blue, right, after we take out our greatest common factor here in red, that's why I tried to keep it all consistent, in blue, they have nothing in common. The 8xy and the 7 have nothing in common. 5m squared plus 2m minus 1, all 3 of them have nothing left in common. And that's when you know you've factored out the GCF completely, if nothing left in the parentheses in the blue, the leftovers. If none of that has anything in common altogether, and I don't just mean the 2 m's here, all 3 terms, then you factored out your GCF appropriately. All right, so let's use this idea to factor by grouping. Okay, if a polynomial has 4 terms, we're going to try these steps. And I use bullets rather than steps because we don't necessarily always use all of the steps. So here we go. First, we're going to factor out the GCF. I see 6p squared, 10p, so I'm thinking even numbers in p. Oh, and then I get to 15. So even numbers, not in common to all of them. P squared, p, oh, that doesn't, I just said pp in the recording. Sorry, I'm definitely middle-aged, but I have the humor of a small youngster in middle school. There's no p with the 25, so they're not all even numbers, they're not all multiples of 5. They don't all have a p. There is no common factor for all 4 terms. So what we're going to do next is we're going to group the first 2 terms and group the last 2 terms. And when you group these, I encourage you to underline rather than use parentheses. Parentheses can really mess us up, and I'll show you why in the next example. Now, factor out the GCF of the first 2 terms. So 6p squared and 10p, we already know 6 and 10 have a 2 in common. P squared and p, they each have at most 1p. And what are we left with? Here we are left with 3p minus 5. Now, we'll always use this sign in the middle. And then I look at 15p and 25, and it looks like they have a 5 in common. So all we're doing by factoring is dividing. So 15p divided by 5, that's 3p. Minus 25 divided by 5, that's minus 5. Well, would you look at that? The things in blue are the same. All right, so factor out the GCF of the first 2 terms, factor out the GCF of the last 2 terms. Now check it out. This is just like our last example on the previous page. Go back and see it if you need to. These 2 terms, separated by a plus sign, have a 3p minus 5 in common. And when I take that out, what am I left with? 2p plus 5. And we have now factored by grouping. All right, we group the first two, we group the last two, and factor from there. Let's try it again. Okay, so we're going to group these first two. 8 and 12. Yeah, they're both even numbers, but more than that, they both have a 4 in common. All right, 4. I have an m squared and I have an m, so that's an m. It looks like that's all they have left. Let me check. 4 goes into 8 twice. M squared, if I take out an m, that leaves me with an m. 12 divided by 4 is 3. I took out the m, but not the n. All right. Now we'll use the sign in the middle, minus sign. And we'll group the second two. Now, the second two definitely have that negative in common, but let's look at the 10 and the 15. It looks like they have a 5 in common. Okay. Let me see. That's it for numbers. M and n squared. So they both have an n. Good. Let's see what we have now. Negative 5n. So negative 10 divided by a negative 5 is 2. I have an mn. I take out the n. I'm left with an m. Negative 15 divided by a negative 5 is plus 3. I have n squared, but I took out one of them, so I have an n. Well, would you look at that again? It's almost like this technique will always end up so that the remaining parts that I've written in blue here are the same for the two terms, and we write what's left. All right, so we can factor by grouping, and we're going to keep that in mind, but we're going to move on to a different form first before we come back to this factoring by grouping. Trust me, there is madness to my method, but there's also a method. Okay, so when we factor quadratics of the form x squared plus bx plus c, our goals are to find two numbers m and n that multiply to make c and add to give b. So I use a little chart and I put multiply and add. So multiplies to be c, adds to be b. And I write down all the factors and then I add them and see how it works up. And these ones, as long as you have an x squared with a 1 coefficient, they'll always factor as x plus m times x plus n, where those two numbers m and n. Now here's some hints, and we're going to kind of walk through the hints as I walk through the problems. So because the 14 is positive, right? Same sign or opposite signs. So the sign of C will tell you if they're positive, they have to be the same sign. Why are they the same sign? Because I want two things that multiply to be 14, positive 14. So that's a negative times a negative is positive, or a positive times a positive is positive. All right, so 14. So I want to multiply to be 14. So that's 1 and 14. That's 2 and 7, and that's it. And then this one tells me, since they're the same, they have to both be positive. And I want to add to be 9. 1 and 14 add to be 15. 2 and 7 add to be 9. So I have found my two numbers, m and n. And so I know x squared plus 9x plus 14 factors as x plus 2 times x plus 7. All right. Now, C, if C is positive, they have the same sign. If C is negative, we have to have opposite signs. A positive times a negative was the only way to make it negative, or a negative times positive. Now, the sign of the numbers, if they are the same, so that positive in front of the 9 told me, oh, since they're the same, they're both positive. Let's see what else these little hints can give to us. Let me see if I can get it on this page here. I am going to not do that. Well, okay then. I have to find my cursor. It'll make sense in a minute. No, it probably won't. There's really no need for me to do that. I'm just wasting time here, it turns out. come out of there to, there we go. Now when I factor again, oh look at this, these are all bad examples, but that's all right. I am going to do it anyway. Gotta wait for my drawing tools to come back for some reason. There we go. The same sign, they must both be positive. I want to multiply to be 15 and add to be 8. I have 1 and 15, 2, no, 3 and 5. Oh look, 3 and 5 add to be 8. This is x plus 5 times x plus 3. Again, we want to multiply to be 24. We want to add to be 3. Multiply to be 24, add to be 3. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. But I need them to add to be 3, 25, 14, 11, 10. This one is said to be prime. All right, because we cannot factor it. Now I'm going to give you some bonus examples here because I can't believe I did that to you. Let's look at x squared plus 5x minus 6. Okay, so I'm going to write the factored version over here. And this is the way I think myself through it. To get x squared, we'll have x times x. To multiply to get a negative 6, one has to be positive and one has to be negative. Right? In order to get a negative, they have to be opposite signs. So I want to multiply to be negative 6 and add to be 5. Now, since my result is positive, I know the bigger number is going to be positive, right? They have to have opposite signs. It's a negative 1 and 6, and negative 2 and 3. Why do I know the bigger one has to be positive? Because if the bigger one is negative, when I add them, the result is negative. So clearly, negative 1 and 6 are going to be the 5 we need. So negative 1, positive 6. I'll give you another example, just these are bonus examples. See if I can find a good one here. X squared minus x minus 12. So I multiply to get a negative, start here, sorry, x squared, that's going to be x times x. I multiply to get a negative, so they'll have opposite signs. I know the bigger one is negative, so I want to multiply to get a negative 12 and add to get a negative 1. So the bigger one is negative. Oh, look at that. 3 and negative 4 makes it work. So a positive 3, a negative 4. And we can still find the factored form. All right, so there's 3 out of the 4 different ways we can have it. We could have a positive at the end and a negative 8x. The only thing that would change is both signs would be negative. All right. So we're going to use a little bit of this idea, especially this chart, along with the factoring by grouping. And with this, any polynomial that's factorable over the rational numbers, you'll be able to do it. Here we go. I want to stop doing whatever it is that I'm doing there. Okay, here we go. First, we're going to factor out the GCF. I have a 15, a 23, and a 28. And I can already tell you this is a bad problem. So I need to get my cursor here again. Of course, I'm having difficulty doing that because that's what happens sometimes in the middle of a recording. I noticed that there was no x in this particular problem. So let's throw in a variable and see if that helps us out. See if we're able to actually factor it now instead of it being a non-example. Now, okay, so factor out the GCF. They don't have one. Multiply A and C together. So our A is 15, our C is negative 28. And 15 times a negative 28 gives us a negative 420. Now, I want things that multiply to be a negative 420, but add to be a positive 23. Now, I am not going to start with negative 1 and a positive 420 because I'm looking at 400 itself, and that's going to be huge. So what I'm going to do is not list all those. I'm going to look at negative 15 and positive 28 because I know this distance happens to be 13. So they need to be a little bit further away from each other. So I am going to try negative 20. What do I have to multiply 20 by to get 420? I have to multiply it by 21. Oh, well, that's only a difference of 1. So it looks like I need something in here. Well, I know that negative 10 and 42 will give me a result of 32, so I'm not quite there. It has to be in between 10 and 15. So I'm really hoping that negative 12 goes into 420. And it does 35 times. Negative 12 and 35, oh, look at that, that's 23. So I don't necessarily do all the factors. I start with the first one, and I realize my task is daunting. So then I went with the numbers that got me there. And I knew that they were not far enough apart, so I tried something else, and I realized I went the wrong direction. And so I could just keep trying numbers and narrow it down to find where it needs to be. So when we multiply A and C together and then find the factors of AC that sum to B, what we're going to do now is rewrite this as 15x squared minus 12x plus 35x minus 28. So I am going to erase these little blue marks to indicate better that positive 23x has been rewritten in terms of the middle term from our factors over here. And now we'll use factoring by grouping. So we'll group these first two, and it looks like they have a 3x. Leaving behind, I'm going to use black. We've got a little bit of blue going on here. 5x minus 4. Use the sign in the middle. And what do 35x and 28 have in common? It looks like they have a 7 in common. 7 goes into 35x 5x times. Minus 28 divided by 7 is a negative 4. Look at that. They both have a 5x minus 4. And I'm left with the 3x plus 7. So all of these come together in order to do the AC method of factoring quadratics. This is a little bit of x squared plus bx plus c, a little bit of factoring by grouping, and it all starts with the GCF. All right. I think I know why I wanted this one on another page. So let's go ahead and do that. Here we go. Let's try number 2. Number 2, I am going to bring down a little bit. There we go. So number 2, first we start with 6 times 3y squared to get 18y squared. So we want to multiply to get 18y squared, and we want to add to get 11y, right? Because the x squared, that's our variable. And I know y is a variable also, but it's tagged on the end, so this could be hard. Let's see. Focus on the 18, right? And when we add, we need a y, so they'll each have a 1y also. Positive 18, so they're the same sign, add to be 11. 2y and 9y. I don't need to go any further because I know those are my numbers. So I have 6x squared. And then instead of calling it 11xy, I'm going to add 2xy and 9xy and my 3y squared. So I used my two found numbers to separate that middle term. I'm rewriting that middle term. Now what do I have? In these first two, it looks like I have a 2x in common. I'm just going to stay with one color here. No, I won't. It's so much easier to see the difference if I write it separately, so let's not be lazy. 6x squared, if I take out a 2, 6 divided by 2 is 3. X squared divided by x is x. 2xy, I take out the 2 and the x, I just have a y. So we'll use the sign in the middle. 9xy and 3y squared have a 3 and a y in common. 9 divided by 3 is 3. xy, they take out the y, I'm left with an x, plus sign. 3y squared, I took out the 3, I took out a y, but I still have one of them left. And I can now factor this as 3x plus y times 2x plus 3y. And I didn't look for a greatest common factor first, but that's because once I saw that 11, I pretty much knew it wasn't going to happen, but I should have said something. I should have reminded you to do that as well. All right, last three examples. We're going to go over a little over 30 minutes here, but that's just what happens sometimes. All right, let's not be all fancy with color coding. Let's just do each problem on its own. So here we have 6 times a negative 35. So we have a 6. Let's turn it on. 6 times a negative 35, negative 210. And it adds to be a positive 1. So I know these numbers are really close to each other. So I know that the biggest number has got to be positive. So a negative 6 and a positive 35, these are different by 29. So let's get a little bit bigger here. Negative 10 and a positive 21, they're different by 11, but I want it to be a 1. Negative 30, that just seems way too big. Let's not jump the shark there. Let me see what else goes in. Let's try 15. Let's try 15. So 210 divided by 15 gives us 14. Oh my goodness. That's a negative 1, but I want the result to be a positive 1, so I should have used a negative 14 and a positive 15. I have to make sure the sign is correct. So now I'm going to rewrite this as 6x squared. I need a positive 1x. All right, so that's a negative 14x plus 15x minus 35. The 6x squared and the 14x have a 2x in common. I'm left with a 3x minus 7. Use the sign in the middle. 15x minus the 35, they have a 5 in common. That leaves me with a 3x minus 7. Oh, that makes sense, because the 3x minus 7 is now in common, and we're left with the 2x plus 5. Factoring by grouping is really the AC method. It really is just the AC method each time. All right, I'm going to give us a little more space for this one, just in case. Okay, 4x squared minus 7x plus 3. We take the 4 times the 3 to get 12. And we want to add to be 7, negative 7. So it looks like this is going to be a negative 3 and a negative 4. Right? Negative 3 times negative 4 is a positive 12. Negative 3 plus negative 4 is a negative 7. So this becomes 4x squared minus 3x minus 4x plus 3. All right, don't forget the plus 3. These first two, they just have an x in common. I'm left with 4x minus 3. Bring down the sign in the middle, that's a negative. Now I'm looking at 4x plus 3 minus 4x plus 3, and I think they don't have anything in common. But don't forget about our friend the 1. Because 1 goes into anything, we could always factor out a 1. So negative 4x divided by a negative 1 is 4x. 3 divided by negative 1 is minus 3. And look at that. The sign in the middle, that negative, took care of the changing of the sign of the 3 so that these are the same. So we'll have 4x minus 3 times x minus 1. Oh, let's circle that. That's a good answer. Let's circle that. All right, the last one. We're going to do this one in green. Green for go. Green for it's the last one. Okay, stop. There we go. Now, 12x cubed minus 87x squared plus 21x. My first thought is I have to find things that add to be 87. So I need to go back a little bit, and I need to remind myself to look for the greatest common factor. 12 is a multiple of 3. That's 3 times 4. 87 is a multiple of 3. I don't really know what the multiple is, but I can find it. 87 divided by 3 is 29. And 27 has a factor of 3. So my GCF definitely has a 3, and look at that. They all have x's. So I'm going to take out a 3x, and I'm left with a 4x squared minus 29x plus 7. So now I'm going to just focus on this 4x squared minus 29x plus 7. So I'm only going to worry about what's inside of the parentheses now. I'm going to multiply 4 times 7 to get 28. And I want to add to be a negative 29 if you need to. Multiply and add, throw the MA over top. It's the first part of math, right? MA. So I want to get a 28, but they add to be a negative 29. Definitely a negative 1 and a negative 8. So 4x squared minus 1x minus 28x plus 7. Don't forget your 3x out in front of it all. And I'm going to do this a little weird. It's going to have huge parentheses. We've got some parentheses going on here. That's all right. We'll take a look. 4x squared minus 1x. They both have an x. And I'm left with 4x minus 1. The sign in the middle is negative. 28x and 7 have a 7 in common. Minus 28x divided by a minus 7 is 4x. 7 divided by a minus 7 is minus 1. We'll look at that. I now have the 3x from the greatest common factor. I have the 4x minus 1, which these two terms inside the giant parentheses have in common, and I'm left with x minus 7. So this AC method will work even when it doesn't start out as a square, because eventually you could greatest common factor, or factor your way out down to a square. That's all factoring is. And if you remember this chart, if you make this chart every single time, you're going to get there. Calculator by your side if you need to, make the chart, list all the factors. If you need help with this, hit me up, mathwithtuesday@gmail.com. Unless you're one of my students, then please use my university email. If you want a handout, something that you could use to practice this a little bit, I have one for you, so let me know. All right, thanks for listening to Factoring. Go factor something. Have a good day.